Hi, my name is Angus Patey, and I'm a professional services consultant here at Fujifilm in Toronto. We are putting together this video so you can better match a supplied swatch or a supplied color from a customer that you want to match in Caldera. So customer gives you a sample and says, this is the color that I want you to match into print. It's not a Pantone color. You don't know what it is. It's just a generic CMYK build or a spot color that they've given you. And they said they want this to be your reference to match in your output. So it's very easy to do, but there's a few steps that we need to go through, and I want to go through that. First is you want to make sure that you have an output profile that is accurate for your device. So in my case, I've got an Epson 9900. I've created a output profile using my spectrophotometer, and I have a really good, accurate profile for that. That's criteria number one. If you don't have an accurate output profile, then the conversion obviously isn't going to be 100% on the output. The next part of it is we want to go to Illustrator, and we want to create a spot color that's going to be referenced in Caldera. So in this case, Staples Green, I've created a swatch called Staples Green, and if you're pretty observant, you'll see that it's not green, it's blue. And I did that on purpose so that we could see that it's actually converting that file in Caldera to the requirement that, or the measurement that we're going to make here. So that is kind of not how you might do it. You may make it a green color. That's fine. In this situation, this example, I want to show you how it's going to convert. So the most important thing is that it's a spot color that is being set up. The color type is a spot color, and that you know what the name is when it comes into Caldera. So we have Staples Green. I've called the file Staples Green, all pretty simple and pretty green. We're not going to save that because I've gone through it, but let's load that file into Caldera, and I will bring it in and saying Staples Green and open. So now we have Staples Green, and as you expected, it's coming in blue. I've loaded it into my Epson printer driver, and I'm going to go into the spot color dialog box. And I'm going to go to details, and I'm going to select the color, and you can see that it's blue as we expect, right? We didn't expect it to do anything because we haven't changed anything. So there's two parts to this dialog box. The top half is your input. This is what is being referenced when it's going to print it, and the second part is your output, and it's going through the ICC profile. It's using ICC. So both of these are using the IC to calculate it. This CMYK value is being created from the CMYK value that I gave in there. That's how that cyan is being created. But we don't want that. We want to reference the sample that the customer's given us. So we're going to make sure that we have an I1 plugged in. It can be the newer I1, or you could use one of the older ones. These ones are still fine for doing this type of color sampling. We're going to click on the spectrophotometer icon. It's now found that, and we're going to click Calibrate. So one click of the button. And now it's saying position it on the sample and take a measurement. So I'm going to place it on there, and I'm going to take one click. And now we have referenced the LAB value for our supplied color. This is a very accurate way to reference the color because it's looking at the exact color values that are supplied. It's better than trying to put a Pantone swatch book down and fan it across and try and find it, or to go into your program and try and build CMYK builds. It's finding the color, it's automatically referencing it, and it's going to use that measured color. So we want to save that into the default input library, right? So we're going to say save. So now Staples Green is in the default color library. It'll be there forever and ever. Our output is calculated based on the ICC profile. So we could print that and see how close we get, and I have done that. And I was able to get a reference value that was fairly close. If you take a look here, you can see that my value is pretty good. You know what I mean? It's not perfect, but I was within 2.6, I think, is what I end up measuring. So if I use my great device here and I measure the sample, and I come back or the reference, and I measure my printed sample, I'm getting a 2.71 value on there. Okay, 2.71 is not bad. Ideally, when you're printing the colors, you would like to have them under a 2. in a perfect world, it would be less than a 1. So color in delta E, 1 and lower is considered pretty much a perfect match. Under a 2 is very acceptable by a number of clients. Getting above a 3, you're starting to see some fairly significant deviation. And a 4 and a 5, 99% of customers would not accept. So the internal conversion is saying a 0.3. The reality is it's a 2.7. So that's not perfect. It's not where we want it to be. We want to improve on that. So to improve on that, we've got to change these output values to something that's going to match more closely to our reference. To do that, we can use color books and we can output a series of swatches. We want to make sure that CMYK is selected, and we're going to calculate the number of swatches that are there. I am going to just go through this and do only the ones that I need. Okay, so I'll just pause this for a second. I'll come back after I... Okay, so I calculated the number of pairs, if you will, that I need by looking at the combinations. I don't need magenta, yellow. The ones that have zeros don't need to be in there, so I don't need any magenta. I don't need any orange, so those weren't included. So, these certain combinations just don't exist in this grouping, so I don't have to include them. And I went 3 samples in each direction, 3%, because I'm already pretty close. I don't need to go 10% away because I'm really only 2.7 delta E away. If I was 5 or 6 delta E away, I'd probably want to increase the percentage of range from the original to make sure that I got a bigger sampling area. So this really determines if you're already pretty close, you can keep it within a tight range and go 3 samples in each direction. Each one is going to be a 1% increment, or you could go more higher, right? It really depends on how close you are to start to how big of a range you're going to do. So if we were to export this and print it, we would then be able to get a reference. So I've already done that as well, just in an effort to save time. And I have my swatch book. What I was able to do is visually take my sample book and go along here and say, okay, well, this area is where I'm the closest. I then used my trusty X-Act and I started measuring those samples. And I got down to one where I got like a 0.65, right? So again, we're happy when we get under a 1. One of them I think was even a 0.5. That was 0.6. I measured it a few times, I might end up with a 0.5. 0.63. Very happy with anything under a 1. So those CMYK values then become my new output reference in here. So I'm just going to read through these. So this is going to be 6, 0, 98, going to be 25, 25, and black is 21. 21, there. So just double check. We've got 6, 98, 25, 0, 21. Great. So that's our new output value. I'm going to save that. It's going to become Staples green. I'm going to say save, and that will then become the new locked in value. So I've also done a print of that. And now, based on that new reference value, we have a new color target that we've printed, which is this one. This one now is very, very, very close. We've got a really close match between these two. And when I measured that, I was getting it down into, as we hoped, a 0.6, right? So now our delta E is a 0.6 to the reference value. Again, anything under a 0, anything under 0 is 0, but anything under a 1 is considered really, really, really close. And no customer would ever complain about that. There's always going to be customers who complain, but that's a very, very close match. So again, it's important that we save it in our input library. It's important that we save it in our output library, which is now this. And if we were to start fresh, right, quit that, delete this, go back to the trash, delete that, and start fresh again, if that file came in a week from now, right, and customer said, we want to keep matching, as long as you have Staples green as the input spot color, Caldera is going to reference that value. Now, something that's very important to remember is this is a dynamic library, which means it's referencing this media profile. If you were to change the profile, you would have to go through this process again in order to be able to get a match, because every profile has a unique set of output variables or output values in order to get a match. You're not going to be able to use the same CMYK values for every profile for every media, right? You're going to have a unique set of values for every media, and that's really important. And it's good because it means that you can calculate the exact output color to get them all to match really closely under a 1ΔT, but you have to go through this process for the different resolutions and different medias. And they are stored in the dynamic color. So this is found in there, and it has made the conversion. If we were to print this again, this color would be mapped to that. So that concludes our color matching from a spot color. I hope that was helpful for you. If you have any questions, feel free to reach out to us. Again, Angus Patey at Fujifilm. Thanks a lot. Bye.